Hi, Paul.
Hi there, it's me again.
What have you got here today?
Today we have a Pioneer SX950 big old high power receiver from the 70s. Very heavy, very handsome, very analog, and it had one channel blown. Not a surprise. Here's the power amp out of it. It sets up in the back of the cabinet. This channel's bad. Two resistors burned that go from here to the bases of the outputs. Emitter resistors all good. These are all good. Basically, four bad output transistors and two drivers, slam dunk. Put factory number parts from the internet in it. Put it all back in here, hooked up all these wires. I mean, there's a, which way does it go? It goes this, that way. Bunch of wires had to be reconnected. Plugged it in and boom, blew out.
Blew out the transistors?
Well, one transistor shorted. So I shut it down, pulled the amp, found one of these transistors bad, so I replaced it with a pair of different stock, some that I actually already had in stock, and put it all back in there. These checked good. And it didn't blow the fuse this time, but it pulled way too much current, and the midpoint voltage kept going up and down, fluctuating. So I shut it down, pulled it out again. These checked good with the Simpson. These checked good, the resistor's good. So I took it to my other shop where I've got a Huntron signature analyzer and ran it up and down these and of course everything else, and found a signature difference between the emitter and collector on this channel. The one I had put new transistors in, the signature was good. The one I had not replaced, the signature was bad. What should be an open emitter to base, emitter to collector junction was checking like a diode, which is wrong. If you take out one transistor, the signature wasn't too bad, but two of them in parallel, bad signature. So I'm going to put two new transistors in that I already had in stock that did not come off the internet. I bought these years ago from a place called Aura. They're out of business. And give it another try. This is an hour's work to take this thing out, fix it, and put it back. But it's worth doing. It's a beautiful receiver. Very handsome.
Well, how many transistors got blown in this whole thing?
Well, originally it had 4 shorted outputs. One goes, the others go with it. Took out the drivers and took out the resistors that go from the drivers to the outputs.
Was it a bad brand new transistor in some cases?
No, this was an original. It's a 40-year-old amplifier. They do eventually die. So I thought, well, I'll order a set of transistors off the internet because they're cheap. They look like original transistors. They don't look like they've been renumbered, but I have a feeling that they've been renumbered. So I put some new old stock that I had in it, and I'm going to find out in a little while whether it's going to work this time.
It's a lot of work putting this together, isn't it?
It is a lot of work. But I've got an inline amp meter, which has a ×10 scale, so you can really measure the current to get your idle current right. And when it slams the needle and you turn it on, you know you got a problem. You shut it right off before you blow something. I've got a variac sitting on the floor down there. Start about 60 volts, right down here below you. About 60 volts, and ease it up so that you don't fry something. Takes a little patience, but this should have been a quickie. You know, 2 outputs, 2 drivers, 2 resistors, bingo, that should have been it. But no, I've got 3 days in this thing now, and I'm still changing parts.
Well, at least it's a good story, and we may learn something from it.
Well, hopefully. It's a simple amplifier. There's nothing complicated about it.
Look at the wire wrap. You don't see that much anymore.
Oh, thank goodness for that. And you think they'd make this thing plug in, but no. But it's a really simple amp. Differential amp, pre-driver, driver, outputs. That's it. Of course, it's got a plus and minus, power supply, no output capacitor. Very simple, but never bypass your process. I should have used the variac the first time and didn't. I thought, it'll work. It didn't. Got the variac, got the amp meter, watched it, fired up. Amperage, it starts low, then it shoots up. So I know something, it's an active problem. My guess is these transistors are just real leaky, but they don't show up with the Simpson ohm meter, which is my gold standard for checking transistors. Yeah, you can get a Cricut and do a trace on them and all kinds of other things, but the Simpson doesn't lie. But these transistors did not show to be leaky enough to be a problem, but you put them in the amp and by God, they're leaking.
Well, that's a good lesson learned there, Paul.
Yeah, I put these new transistors in. I'll see if I'm full of shit or not.
Yep, the process is important.
Yeah. Yeah, usually when you find one that's pulling too much current, you check your bias diodes and the bias pot and whatever forms the bias control circuit. This will check good.
Well, thank
So-
you, Paul.
We'll have more to report later.